Welcome everyone to this session. We're going to be talking about connecting the dots with DataHub in the Lakehouse and beyond. It was very interesting because I just walked in. I always have the nerves before getting up on stage, so I always like to watch the previous speaker finish up their talk. And my ex-colleague, Ian Liu, was up here talking about the DoorDash data journey. And there was a gentleman in the audience who asked one question at the very end. So all of this is great. You've got end-to-end visibility within the Lakehouse, but what about beyond? Where did data come from? Where did it go? And I was like, wait for the next talk, because that's exactly what I'm going to be talking about. So welcome, everyone. I'm Shashanka Das. I'll be talking for the next 30 minutes or so about DataHub. I'm the CEO and co-founder of Acryl Data, and also the founder of the DataHub project, which I helped create while I was at LinkedIn prior to this. I also tweet at Shashanka. Acryl Data is a company that was founded early 2021 by data engineers from LinkedIn and Airbnb. We're still getting started, but our mission really is to bring clarity to complex data ecosystems by driving forward the open source DataHub project. And also, of course, we have a cloud offering that takes DataHub to the next level. So I have only said DataHub about 5 times so far during the talk, but you'll hear me say it about 100 times after this. But let's talk about what is DataHub. DataHub is an open source metadata platform that provides a high fidelity metadata graph. And think of it as everything that you care about in your data ecosystem. Data sets, dashboards, streams, tables, pipelines, models, features, and people who are continuously in and out of data. All of this versioned and controlled, and on top of that, use cases, multiple use cases like discovery, observability, and governance. That's basically what we are building towards. The project itself has taken off in a pretty big way over the last year and a half, primarily due to obviously the open source nature, but really because of the large number of integrations that we have with pretty much every single technology in the modern, postmodern, pre-modern, the entire data stack. You'll see the usuals, dbt, Looker, Snowflake, Databricks, Spark, Kafka, and all of the usual suspects, but also a lot of more esoteric systems out there. It's also getting used a lot by a lot of new companies, modern companies like Peloton, as well as slightly more complex companies like Optum or United Healthcare. So we're seeing quite a bit of adoption across multiple segments because this problem clearly is something that resonates across. My clicker clearly doesn't work. DataHub also has a very vibrant Slack community. Actually, the slide is already out of date. We are at almost 4,000 members right now, and they're really spread across the whole world. Most of them are, as you would expect, data practitioners, data scientists, and data engineers, as well as data architects, who are basically there because they are working with DataHub, POCing DataHub, or they have heard about this problem, and they're here to discuss how to get data governance right, how to make data discovery delightful and easy, and how to kickstart metadata initiatives at their company. The community is also pretty active, lots of messages. We have monthly town halls that regularly get more than 100 people showing up. And the project has also grown quite a bit. We have more than 200 contributors and a huge rate of commits every month, which leads to the project actually making huge strides every month. And so that's been pretty amazing to watch. So, quick, show of hands, I guess. How many people here had heard about DataHub before they came here? Okay, a few. So let's do a quick intro to what DataHub is and what you can do with it. And the best way we found to explain what DataHub is and how it works is by working through the journey of a fictional company. This is actually a company that we came up with because we are all pet lovers at Acrel. And we said, well, how can you mix data science and our love for long-tailed furry animals in a company? And so Longtail Companions was born. It's a pet adoptions company, and their data stack would look very familiar to a lot of people, hopefully. It obviously did not start out fragmented. They initially had an adoptions team, and they were building out an adoptions website. So that included storing their metadata, the transactions data in Postgres, and maybe some document-oriented data in Mongo. And that went very well, and the adoption site started working pretty good. And the founder said, it seems like people who adopt pets also want to buy stuff for them. And so they started up an e-commerce division. And that obviously wanted to store purchase orders and things like that. And they also wanted to create a data science team that would create recommendations for matching up pets with adopters, as well as matching up adopters with what they would buy next. And so a fledgling data science team was born. They said, well, let's use Kafka for collecting all of this event data that's coming our way. And so a few more technologies got added. Very soon, the business actually took off pretty rapidly, and then a data platform team was introduced. And they said, well, to really scale out this kind of analytical processing and ML that you're doing, we need to set up a lakehouse. And so they ended up using Airflow to ingest all of this data into S3, and then moved it over to Databricks, and they were using Spark to do a lot of data transformation and cleaning and extraction. And then an analytics engineering team came in, and they brought in dbt, and they said, well, we can now start producing insights and surface them up in Looker. So that's a very quick journey into how a company went from being very simple, very easy to understand, to quite a few technologies thrown in very quickly. And this is actually a very simplified diagram. Obviously, you know this for a fact. A lot of your companies are probably running multiple of these technologies, even in the same segment. So what gets hard when this happens, right? The main problem that happens is that there are a lot of personas involved here, and they have a lot of questions that they routinely ask and struggle to answer. For example, the data platform team, which is smack in the middle, that was actually my past life at LinkedIn, is responsible for producing and making sure that data pipelines are running on schedule, that the core data sets that are being produced are of high quality, and the analytics team and the ML engineers can actually use it with reliability and assurance. And their biggest problem is there's so much out there, they don't know where to focus. So they need to always be running around asking people, is this important for me to worry about? Is this pipeline important for me to rescue versus all the other pipelines that seem to be in trouble this morning? So they have a big problem of saying, I need data to be up to date and accurate and reliable, but I don't know exactly which things to focus on. The analytics engineering team, which was growing pretty rapidly, people were coming in and they were being asked to produce insights pretty rapidly. And their main question was, well, what is the authoritative data set that I can use to start building these insights, these models? And they found that just looking at the lakehouse wasn't enough. Oftentimes, they would have to go upstream and talk to the teams above that to figure out whether something was authoritative or not. And then finally, don't forget the data science team. They are on the hook to deliver high quality recommendations and high quality matching. And one of the things that the founders actually did early on in the creating of the division was they wanted the e-commerce division to be very separate from the adoptions division. And so they did not want any commingling of PII data to be happening. And so the data science team really wants to make sure that their ML features are able to exclude PII whenever they run. And that's hard because data is getting transformed and going into the lake and coming back out, and there's so many steps in that transformation process that it's never clear if things got commingled in the middle. So what's the solution? Well, at least the key to the solution is metadata, right? Hopefully a lot of you have a rough idea for what metadata means. It's the schemas of tables and the business context of things, and also the operational metadata like pipeline run events and statistics about data sets, and all of that is metadata. And the key to solving this problem well is to have a holistic approach to dealing with this metadata siloing that often happens across a lot of these platforms. And I'll skip straight to the cliff notes. If there's one thing you need to remember from this talk, is that it doesn't matter what tool you use, it doesn't matter how you run your governance initiatives, but there are really three things to remember when it comes to metadata management. And these are kind of the learnings I personally have had, as well as what I've seen work in the industry across my decade of trying to make this happen for a lot of companies, is that you need to have a really comprehensive approach towards metadata. We call this metadata 360. You need to be able to shift left your metadata practices into the developer workflows and the places where data is actually getting authored. And finally, you need to have an active metadata management strategy, which means metadata has to be really live and active, not something that is just in the human plane. And I'll talk about, with DataHub as the reference implementation for this, what does that look like? So metadata 360, before I go into that in a lot of detail, the first step, of course, is integrating. So to get a lot of comprehensive metadata, you have to integrate with all of these different systems I talked about. And since this is Data and AI Summit, I'm going to talk about, obviously, the Spark ecosystem. DataHub has always had pretty good integration with Databricks Hive, which means as long as you have your Databricks workspace URL and connectivity to it, you can just point DataHub to that instance, and it'll essentially fetch all the tables and all the schemas, et cetera. But today, we are very glad to announce that we also just announced Delta Lake integration, which means that it doesn't matter if you're on Databricks or off, but as long as you're using the open Delta Lake format, you can just point DataHub to the Delta Lake folder or the folder that contains all of the Delta Lake tables. And DataHub is going to basically scan it and use the Delta standalone module, thanks to the Databricks team open sourcing it, get all of that metadata out. But that's not all. You have all the tables coming in through these integrations. And that's what a Delta Lake table looks like on DataHub. But in addition to that, we also have what we call push-based integration with Spark, which means that anytime a Spark pipeline runs, you can push the definitions of the pipeline as well as the tasks within it, along with lineage that the tasks are actually processing. So all the data sets that the task read and all the data sets that it wrote to are pushed when the job runs. And all of this has become very simple. All you need to do is just add a little config parameter to your Spark pipeline, or you can set it in the cluster conf as well, and provide it basically the DataHub Spark listener. You just need to provide it the jar and a pointer to the DataHub metadata service. And every single run of every single Spark job and pipeline will then get emitted to DataHub. And that ends up looking on DataHub something like this. This is a local instance where I was running a Spark job. You see the pipeline and you see the individual tasks within it. And then you see the lineage view where for each individual task, you can see what were the input tables as well as the output tables or folders. And we, of course, capture everything at a run level, so you can go back in time and look at how the lineage changed over time as well. So that's the integration recap, right? When you connect up to Spark, here are the things you can get from the jobs. You can get pipelines and DAG definitions and lineage. And from the table side of things, Databricks Hive or the new Delta Lake connector, you can get schemas as well as statistics. And with Delta Lake, we are excited that we'll be able to get the transaction log as well. So you can get every single edit, every single operation that has happened to the data set. We're also working on Unity Catalog integration, so that's coming next, which means that pretty much any form of space you are in the Spark ecosystem, you'll be able to point DataHub to it and get pretty comprehensive metadata coming out. So once you've got all this metadata integrated and in one place, what does searching for that authoritative pet data set look like? So this is an example of just searching for pet profile. And as you can see, it brings up a faceted search experience. You see all sorts of things in there, Airflow pipelines, glossary terms, and some data sets as well. Some data sets are on the lake, and some data sets are in operational systems like MongoDB. And for someone who's just confronted with this mess, it can be quite daunting, and that's why the left bar kind of helps you drill down into what is it that you're looking for. Maybe you're a data scientist and you really are looking for the data lake version of the pet profile. or maybe you're actually an application engineer and you're actually looking to use the online version of the same data set. So once you find a data set or an asset that looks kind of interesting, you can view a lot of interesting things about it. Of course, you can view the technical schema, whether it's nested or flattened. You can understand how it's getting used. So statistics about row level counts, width, how many queries are getting done against it. Is this an active asset that's under use? And when was it last updated? Right? Also understand business context. So this is where kind of the business metadata comes in, being able to attach social tags as well as glossary elements so that you can say, oh, this is actually a sensitive element, or this relates to the customer domain, or things like that. And then, of course, most importantly, identify the right humans, because the tool can only tell you so much, but then you might have to send a message to someone to say, hey, I'm about to use this data set. Was my guess right? And what this does really is takes the central team out of the picture and allows the data producers and consumers to really self-serve and understand context quickly. Finally, we also have operational details, so live and historical views of the statistics of a data set, column level, as well as over time. So you can actually see whether this is a reliable data set or not. And of course, finally, being able to look at queries that have been done against the data set, frequent queries, so that you can figure out what kind of query should you be writing against it. Is this data set usually joined against some other table? Things like that. We recently launched integration with data quality tools. So if you're running Great Expectations or DBT tests or even your in-house data quality tool, you can send data quality assertions as well as the results of running those assertions into DataHub as well, which allows you to then understand if this is a well-maintained data set, if people have written rules against it, and if those rules are succeeding or not. And finally, I talked about the business glossary. It's a pretty cool concept. Actually, I come from a data infra background, so I ended up building up. But I've recently been exposed to the world of ontologies and taxonomies, and it's pretty interesting. You can build a full logical schema of your business domain. You can say customers and products and orders and kind of have a logical schema for the world, and then attach it to these technical terms. And that allows you to navigate your business context first and then drill down into a technical context. So for example, if the company had created a pets domain and had attached that pet domain to the data set, it would be very easy for me to figure out that's probably the authoritative pet data set. And then you can relate assets to KPIs as well. So in a nutshell, to answer this question, what is the authoritative pet data set, we are able to take technical metadata, all of the low-level stuff that we all know and work with, as well as the business metadata, that's the social and the human context on top of it, and combine it together to form a full 360-degree view of the data asset. There's one small flaw here, though. The business metadata that I'm talking about is usually provided by humans. And in a lot of cases, you end up finding the wrong people to put this metadata in. I've seen a lot of places where governance initiatives are run in a way where there's a central governance team and there's a central data steward team, and they're kind of tasked with going in and tagging all of these data sets and annotating them. And they're trying their best, but they can only keep up so much. What we found just through software engineering practices is that documentation is best kept right next to the code. And similarly, what we found is in a lot of cases, a lot of this metadata is actually in the heads of the people who are producing these data assets. And so we just, as an industry, have missed out on giving data producers the tools to express metadata right next to where they're creating data. And that's what we want to change, and we're calling this the shift left movement, which is being able to declare and collect metadata at source where it makes sense. And I'll go through a few examples of what we're seeing in the community. How many people are familiar with DBT here? Okay, quite a few. So DBT is pretty cool. It allows you to manage your entire warehouse using kind of a standard build and deploy process and a convention around how to write SQL. And also has this very interesting feature. When you describe a model, you can just add in a meta section. And the meta section allows you to capture additional context about this thing that you want to squirrel away. Things like who's the owner, what is the model maturity level, does this contain PII, is this a business critical asset? And all of these are flexible, honestly. It's not like DBT enforces that you must do it a certain way, but organizations can enforce what they would like to see in these models. And what DataHub does is it just maps these into DataHub concepts. So what that looks like is you've got all of this context showing up exactly in the data asset as the data developer intended it to be. So tags are getting propagated, owners, domains, all of this stuff is going straight in. Similarly, we are seeing another kind of movement with Kafka, right? A lot of companies are moving to Kafka as the real-time streaming system. And along with that, they're doing structured event emissions, which means events are coming in with schemas. And schemas are a great place to add all of this annotation as well. So we've got a contribution from the community where we had a protobuf schema, and you can add annotations on top of it to capture business context as well as tags, as well as documentation. And all of that gets reflected into DataHub directly. So what this means is you don't need to go back into the UI and click buttons and restate the obvious things that the data producer already knew. And what this leads to is much higher quality metadata, because when you're making decisions, they're actually based on the metadata that was collected at source. And so when that code changes, when someone goes in and makes a change in the code, they'll see the metadata sitting right next to it, and they'll probably get caught at code review and they'll fix it right then. So answering that question of, what is the authoritative pet profile data set now becomes so much simpler, because not only are you getting a 360-degree view of the data asset, you actually have much more confidence in the quality of the metadata as well. All right, so we talked about two big pillars, metadata 360 and shifting left. And I think you're ready for the last one, which is active metadata. And what that means really is injecting metadata into the operational plane. Meaning metadata is not just something that humans can touch and feel, but actually something that is integrated into your operational data plane. What does that look like? To explain that, first I have to talk about DataHub's architecture really quickly. This can usually be a 1-hour talk, but I'll try to go very fast. All of your systems, your Snowflakes, Lakehouses, Airflow, DBT, GitHub, all of these systems up to the left are really where all the action is happening, right? Even as I was speaking, probably a schema got checked in. Maybe it was backwards compatible, maybe it wasn't. And all of these changes that are continuously happening are getting pushed or pulled into DataHub. And DataHub is keeping it in a beautiful version metadata graph backed by a log. And refinements are running on top of this. Some of them are automated refinements. Some of them are human-in-the-loop refinements. Something was suggested. Does this seem right? That kind of stuff. And once you have a really scaled out version metadata graph, you can do amazing things with it. You can query it to ask questions like, what's the schema of this data set? That's an easy one. But then you can also ask it, what did the schema of this data set look like a week ago? You can also ask, how many pipelines ran in the last week, and how many of them succeeded? And how many of them were Spark pipelines? You can ask, given this data set, how many dashboards are downstream of it, and how many of them are classified as important? You get the drift, right? If you have a really good and powerful versioned metadata graph, you can ask really high quality questions and get some interesting answers that you can do something with. Not only that, if you've got a log, you can actually stream it, which means you can react to changes that are happening in pretty low latency. What that means is if you have a pipeline that just finished and then a data quality run happened and that produced a result, and maybe that result was not so great, you can observe it and immediately fire off a Slack alert or a PagerDuty alert or something like that to the owner of the data asset, or maybe to the downstream owners to let them know that a data asset is probably not safe to consume anymore. And that leads to amazing things that you can do because you've got a system that is live. And so it's not stale. You can actually depend on it not only to go and click on buttons and view results, but actually have programmatic action be driven from it. So to kind of enable that kind of ecosystem, we built something called DataHub Actions, inspired by, I guess, GitHub Actions. Right? So you connect up to DataHub and you basically start watching the stream of events. And you can do things like filter on a particular kind of event you care about. Like in this case, I just want to look at tags that are being added, and specifically the PII tag, because of course, that is the radioactive tag we all want to watch for. And anytime that something gets, PII tag gets added to any asset, I want to do something about it. And to do that, all I have to do is implement the act method. And what could I be doing? Well, I could be doing many things. I could be maybe propagating the tag to a downstream system. I could be maybe notifying a downstream asset owner that, hey, something you depended on that wasn't PII before this is now PII, things like that. So a simple example of this, is remember our long-tail companions, friends, the MongoDB instance maybe got attached to a PII tag, and you watch for it, and then you kind of propagate that tag all the way down. And maybe as lakehouses and warehouses mature, and they start applying tag-based masking policies and things like that, you can actually propagate the tag all the way into the destination system, and then enable essentially automatic governance through this kind of propagation. And this was a very simple example. As you can imagine, there's so many things you could be doing with something like this. There's another common thing that we as data engineers face, which is pipelines that are less reliable than we would want them to be. And that's another typical scenario. Two different teams, the e-commerce team and the marketing team. The e-commerce team is responsible for cleaning the pet data set and producing a core pet data set for the rest of the company to use. And the marketing team is responsible for processing it and emailing senders, potential adoptees, that, hey, here's a new pet. You had indicated you are interested in purebred golden retrievers, and someone just showed up, and so you might be interested in this one. That's kind of the job. Even though it's so simple, a lot of things can go wrong with this, right? You can have delayed data where pet profiles dump got delayed, therefore the standardized data got delayed. However, the marketing pipeline still ran because it's just set to run on a schedule, and it processed old data, and as a result sent out bad emails, meaning maybe a pet was adopted, but someone else got an email saying this pet is up for adoption, and by the time they went in, their hearts all aflutter, the pet was gone, and they went back sad and unhappy, and we don't want that. So what can we do about it? With DataHub, you can prevent pet owners from being disappointed. What you can do is connect up the upstream pipeline and the downstream pipeline with basically a reporting emitter. So the reporting emitter just emits the freshness metric. Every time anything gets added to the pet data set, it just reports up to DataHub that it inserted a bunch of rows, this was the time. And then on the consumer side, you can attach a circuit breaker sensor. So if you're hopefully everyone has played with Airflow at some point. So Airflow has this concept of a pipeline, and at the top of the pipeline, you can add an operator or a sensor to essentially detect something before the rest of the pipeline runs. So DataHub offers kind of a circuit breaker that you can drop at the top of your pipeline, and what it can do is essentially check for whether the data set is fresh enough for you to run. And that prevents a lot of bad data and a lot of bad pipelines from being run unnecessarily. This is a very simple problem. There are more complex problems. Data sets can actually change in subtle ways. A timestamp column went from seconds to millis. I've actually done this personally, but it has also been done to me. And it's never good when something like this happens. Same kind of recipe here as well, except with the addition of a data quality tool, like maybe the Delta Lake statistics or Great Expectations or whatever, right? But the pattern is still the same. After you produce data, you send up a validation report for what were the assertions that you checked and what was the state of those assertions. And the downstream pipeline has just a single circuit breaker sensor running that just checks with DataHub whether these assertions passed. And not only whether the assertions passed, but whether the assertions are fresh, meaning they must have been evaluated after the data set landed. And you can do those things with the DataHub assertion circuit breaker. So that's how you detect quality problems. But tests can't catch everything. There was a time when someone went in and set all the age columns to 0 in the main database. You can't recover from that. The data set is just broken until someone goes in and actually fixes it. And so for that, we have the manual override kill switch. So in Acryl DataHub, we have a feature called incidents, where an owner can go in or an operational person can go in and raise an incident on a data set or an entire slew of data sets that might be affected. And of course, that shows up on the UI. But the operational system can also check for incidents being active on a particular data set and basically refuse to do further processing. So it's the same pattern every place. It's really, we're raising the level of what is it that we are checking. Freshness, completeness, timeliness, as well as correctness. And so that gives you kind of a toolkit of capabilities that you can build on each other, operations, assertions, and incidents that allow you to get pretty reliable with respect to each individual pipeline. But the next thing that we face is that there are too many pipelines and too many data sets. And so going in and fixing each one of them individually by hand is actually not that simple. So the question that we were then trying to solve for the industry was, how do you solve for a pretty overstaffed central data platform team that wants to say, I want generally everything to be reliable, and I want to focus on the most critical data flows, not on every single data flow. And to do that, we brought in a fourth concept called DataHub tests, which essentially takes this three things and applies a layer on top of it. So with DataHub tests, what you can do is define global tests. Things like all tier 1 data sets should have passing assertions. So as you can see, it's not a specific test against a specific data asset, but it's applying an assertion to a category of assets. So you're saying all tier 1 data sets, and so you can define what tier 1 means in a separate place. Maybe it's a tag on a data set, or maybe it's some other characteristic about the data set that makes it a tier 1 data set. And then it should have passing assertions. And each assertion, of course, could be individually written against the data set and could be a great expectation test or a DBT test or what have you. And that's a central policy. So you're defining it as a central policy, and it ensures that you're checking for assertions passing on all your tier 1 data sets. And then as a downstream consumer, all you need to care about is checking if all your inputs are passing these global tests. And as you can imagine, that's, again, very easily doable with another of these sensors. So we have a DataHub test circuit breaker that you can attach to the top of your Airflow DAG. In fact, we have a default policy where you can just auto-attach it, so that way people don't even have to opt into these, and they're opted in by default. And that way you can, with a very little bit of effort, essentially get very high data reliability for your most critical flows and pipelines. As you can imagine, there's a UI that goes along with it where you can go and define your tests, define your matching rules, what you want to assert on, and manage all your tests, look at the reports on whether tests are running successfully or not, and also being able to define a circuit breaker where you can set up the connection, create a test circuit breaker, check if all the tests are passing, and then finally a policy that can apply to every DAG. So this is a very simple way in which an Airflow operator at a company can actually set up DataHub tests for the entire company. And that way we kind of solve that fourth bullet of how do we solve this for scale across the entire company. And that essentially brings me to the two questions that we started with, being able to exclude ML features from processing PII. You can do that with the stack propagation capabilities. And the central data platform team can now focus only on the critical data products and make sure that they're up to date and accurate. So if there's one slide, again, that you remember from this talk, it is there are three must-haves for connecting the dots. The first is metadata 360. The second is shifting left. And the third is active metadata. And now you are ready to connect the dots. You can join our Slack channel. It's a pretty friendly community. We can talk all things data lake and Lakehouse and warehouse. And you can also install the open source package locally. It's pretty easy to get started. And in 5 minutes, you'll be connecting the dots yourself. Thank you.
Thank you. We have 1 more minute if anyone have any question.
Throughout the talk, I think you ended up answering it, but my main question was going to be, how do I go to, VP level and say we need to spend money on DataHub versus Elation? I think one of the things I noticed is it allows us to programmatically kind of at the source of the data generate information. But is there anything else that you would kind of recommend or say this is how we're better than a Munson or Elation or any other metadata cataloging?
I think the question was kind of comparing DataHub to the other similar offerings in the space like Elation or a Munson. Did I hear that right? Yeah. So I think To some extent, I tried to answer it through the talk, obviously, like our ability to shift left and connect up to the developer workflows is actually not something that's available in these other catalogs. And also, most of these other catalogs are apps more than platforms, so they don't really integrate up with your operational fabric as well as DataHub does. It's really built in kind of a platform up way. And the one question you asked was, how do I justify the expense? So DataHub is open source and free for you to use. So you can actually get, in fact, that's how a lot of people get started with it. They'll do a POC or a hackathon, and over a weekend, they'll basically have something pretty interesting to show to their management. And that's when they decide whether to buy it or actually self-host it and run it internally. And that's completely a decision that any team can make on their own.